All right, so back to 2015, both first question. So yeah, we're asked to calculate the pH of this soft drink, right? So what are the steps in which we'll take? We have pertinent information. What do we need to do to calculate the pH of a buffer? What's the equation?
So do we use the same one from the last equation? The last
Yes,
question?
we will. Right, so the same one from
pH
last.
equal pKa plus concentration of salt over concentration of acid.
No,
And that
Plus log of concentration of a
the
salt and
log.
acid.
Just remember the log. You have to take the log of it, right? Salt concentration over our acid concentration. All right. So what are the steps though? What don't we
So
have?
wouldn't it be log 10?
Yeah, it would be log base 10, right? But mathematically, log base 10 is the general log that we use. Every single time you see log, it is log base 10. Unless specified, it is log base 10. If they ask you to find the pH, the Ka or whatever, or the pH from log to the base 2, then you'd have to use the change base formula to get it to log base 10 and then move through. But that is just some math. That's just some math, alright? But they won't give, they should not, I can't say they won't, they should not give you that because this is not a math exam, right? But it's log base 10 generally, right? So log. Every time we see log here, it's log base 10. Alright? So what we're looking at now, the first step would be what now? Step 1. What's step 1? What don't we have?
You need to
So we don't
find,
have the concentration of the salt and acid, and we don't know what the pKa is.
Alright. Okay, lovely. So Anna, would you find the pKa first? I saw Shanique said that she would find the pKa first. And then set that aside. Alright, I guess we're finding the pKa first. So find pKa.
yeah, do that.
Lovely. And our pKa is negative log.
Negative log of 6.4 times 10 to the negative 8.
Okay, 6.4. Alright, and then we times 10 to the power of negative 8. Lovely. And then after that, now what's the second step? Step 2. What do we do next?
To find the salt concentration.
The salt
Which will be
concentration.
more
Find it.
of salt over volume.
Okay, so what we're going to do, we find the number of moles, right? So find the number of moles. Number of moles of our salts. I guess we did that salt first. And then the acid and the acid. Because we can find the mass of the salt and the acid, and then using that, moles is equal to what? Mass divided by the molar mass?
yes, sir.
Yes,
Alright.
sir.
Mass divided by the molar mass. Lovely. And then step 3, now I would actually convert the volume given, which is a 355 cm cube, to dm cube. So I'll convert the volume to dm cube, right? And then how you convert the volume to dm cube now? We take the 355, right? And we divide by 1,000, yes?
Divide by 1,000. Yeah.
Lovely. Step 4. Oh, what's the value that you get? Go ahead. Tell me what they got for it. Okay.
0.355.
Alright. That would be dm
DMQ.
cube. Alright. Step 4 now. After we have that now, we find concentration. Right? So concentration would now be mole divided by the volume. Right?
Volume.
For both acid and base. Lovely. Because sometimes it's not the math is the problem, you know, just sometimes it's the procedure in which we must follow. And then we plug in to the equation. Everybody's fine with those steps?
Yes, sir.
Lovely.
I'm just curious.
Go
Could
ahead.
you have used H plus is equal to Ke, acid on salt, times acid on salt?
Hydrogen ion is equal to K. Oh, that is transposing the Ka equation. Could you use that? I've never used it, you know, so I don't really know. I've never used it. But technically, if you transpose, you should be getting the same mathematical answer.
Okay.
Because that would just be transposing. But that's generally how you get that answer there. Alright. So you should be able to use this to get that. Okay. Anybody see any flaws in the steps so far? Okay. The reason why I'm not working is because I have generally 5 minutes until I should start module 3. And I want to give you guys some time, so I might start like at 10:05 or 10:15. I don't know. Alright, so the last question under the buffers and pH that we'll look at before tomorrow. Hopefully it comes tomorrow. Many chemical reactions occurring in living systems such as the human, occurs in living systems such as the human body, right? Discuss the importance of biological buffers in the maintenance of body health or a healthy body, right? In the maintenance of that it's, you know, remember osmoregulation, remember the pH, right? The importance of maintaining pH in the body, right? We have to understand how biological buffers maintain that healthy body, right? Include an example of a chemical reaction of a blood buffer. What is the blood buffer? The syllabus outlines 3 buffers. What is the blood buffer that the syllabus outlines?
The phosphate buffer.
Lovely, right? And ironically, it's the same phosphates, dihydrogen phosphate that we use up here. Where is it? Okay, it's the same buffer system that we use up here, right? The same. It's not going to be the sodium on it. We're just going to leave the dihydrogen phosphate and then the hydrogen phosphate. So this is the hydrogen phosphate buffer system we're looking at. Alright, the hydrogen phosphate buffer system we're looking at. So all we need to do is write the hydrogen phosphate buffer system and then explain how that buffer system works and then connect it to the health. Blood health or the health of the body. You get it, right? So we've gone over so many buffer questions so far. Go ahead. You have something to say? So we've gone over so many buffer questions so far, and we should know by now how buffers work. This is the last one we're looking at, right? But now explain to me now, discuss the importance of biological buffers in the maintenance of a healthy body. Somebody discuss this, please.
So the biological buffers ensure that the body's pH and their conditions are kept neutral, so they don't become too basic or too acidic.
Red flag. You said the body's pH is what? Neutral? That's not true. Slightly alkaline.
Huh? Oh.
Alright.
Sorry.
No, it's not a problem, you know. But I'm just trying to take what all the fallacies, right? So it's slightly alkaline. So sometimes, when you're writing I'm not sure if I have enough time to do Biology Unit 1 or Biology Unit 2 marathons, right? But when you're writing in like statements and those papers, we do not want to make a bold assumption. We don't want to make bold assumptions. So try your best not to make a bold assumption, but explain the concept. So we want the body to maintain its regular pH. What does regular mean? They can't take off marks for that, right? So maintain the normal pH or the regular pH, alright? So Anna has explained that the buffers help to maintain the regular pH of the body. Can somebody else now explain to me why is it that we need to maintain that pH? Somebody put in the chat. Let's see. Timothy put in the chat. Enzymes will function at certain pH above 7, and the buffer prevents alkinosis and acidosis. Lovely, right? So the enzymes are very important, right? So we know that enzymes drive biological reactions. They're just catalytic molecules, right, that drive this reaction. No. The enzymes the enzymes operate at different types of pH, and within the blood, our blood enzymes tend to occur at a pH slightly above 7, right? So and you know that the enzymes from CSEP Biodays, we know that enzymes have an optimal pH. So if we get too alkaline, right, we're going to have alkinosis. Lovely, as stated, right? And then if it gets too acidic, we're going to have acidosis. So we can see here now how buffer systems are important for the maintenance of health. Alright? So it's just those things you want to mention, especially if they ask you about the blood buffers, right? About biological buffers. It's important. Alright? They could even ask you about the buffer of an ecosystem. They can ask you anything, because what is biology but applied chemistry? So they might ask you to apply the chemistry to different stuff. Even with solubility product questions, they may ask you to look at the solubility product value, the KSPE of a specific salt, and then ask you how to relate that to the formation of kidney stones. We must be able to relate the chemistry, right, to biology, right? So it is important that we read up on how these things work, not just how to plug in number into equation and it's done, but we need to know the importance of what we're learning, right? The beauty of the chemistry. All right. So that is it for the buffer and pH questions.